All right, cool. Okay, so now we're going to talk about databases. So first off, what's MongoDB? Again, MongoDB is a document database, and it is easier to use than the row column model probably for most of us who haven't used databases before. We can imagine that we have some object like this with a name, age, and hobbies field. The name is a string, the age is a number, and hobbies is an array of strings. And we can just store this directly in our database. So why would we use MongoDB? Well, it's nice when we have to write a lot to the database. The structure of the data, if it's going to change often, well, then MongoDB is a good fit because we can very flexibly change what our data looks like. And it's pretty easy to use. So we can imagine that a field, first off, is something like the color of this nice stuffed Shiba here. And it also has a length. And it also has a poofiness factor and an angriness factor. And the Shiba as a whole is a document. A collection would be like a crate of a bunch of Shibas. And the database is like a single storage unit that has many collections in it. But those collections don't all have to be the same kind of collection. So all those individual crates could maybe hold something other than Shibas. They could maybe hold like cats or stuffed cats. And a MongoDB instance is a bunch of these storage units. So it's many, many databases. So in words, let's break that down. A MongoDB instance is a group of databases. A database is a group of collections. A collection is a group of similar pieces of data. And a document is one piece of data in the app, whereas a field is like some property of a document. This structure is pretty analogous to a storage facility. So the storage facility is like our database, like our database instance, like our Mongo instance. And each individual storage unit is like a database. A box is like a collection, and whatever's inside of a box is like a document. And all these boxes have the same kind of thing in them. So now we can take a look at what this looks like in a database. And the database is actually is exactly the same as this, except with like different words. So you can see that structurally they're very, very similar. And it's a pretty good mental model to like think of a database sort of like a warehouse or a storage facility. We've been emphasizing that collections all store the same kind of document. That's not exactly true, but we'd like rather it be true, and we'll be using a tool to make sure that's true. If you have questions so far, feel free to post them at weblab.is/questions. Put yourself on the help queue if you have some setup problems, or post on Piazza. We're going to be talking about Mongoose. It's a library in Node.js that allows us to use MongoDB very easily. And it's what's actually going to ensure that all of our collections have documents that are structurally the same. It's a thin wrapper around the MongoDB API, and it's going to connect to a cluster. It lets us create documents, and it lets us interact with the database. So make documents, update them, delete them, that sort of thing. We're going to go over the code for connecting to our cluster as well in the workshop. But for now, you can kind of think of it as like boilerplate code that you have to write for any app using MongoDB Atlas and Mongoose. So why do we actually need Mongoose? The main thing is that Mongo doesn't guarantee that all documents in a collection are structurally the same. This is pretty inconvenient when you're writing code because it's really nice to know that all the objects you get back from your request to an endpoint will all have the same fields. If you don't know that, then when you access a field, it might be undefined or it might exist or it might have some other type than you expected. And it becomes very hard to write code that handles simple code to handle retrieving objects. So a nice collection, for example, is like this box that only has screws in it. And a less nice collection is like this box that mostly has screws in it, but has one screwdriver. If you make a query and you get back the screwdriver, as well as the screws, you have to somehow know that you have a screwdriver inside of the results of the query. And you probably wrote the code to mostly work for screws, not screwdrivers. So because of that, it's much simpler if our box only has screws in it. The worst possible case is that we have all kinds of things inside of our collection, and we don't know what they actually structurally look like, because then we have no idea what we can actually expect for them to have as fields. So the name for how we specify what a collection, what documents, or what properties documents in a collection have is a schema. A schema defines the structure of your documents. You define the keys and types of values corresponding to the keys. And it lets you really organize your collection in a way that makes it easier to use as a developer. So to define a schema for that code that we talked about earlier, you would write schema, and then you would map name to string, age to number, and hobbies to array of string. And then this document matches the schema. So when we write this schema, what's going to happen is Mongoose will make a collection for us, and that collection will have documents of that type in it. And JavaScript will try to make sure that more, or like specifically Mongoose will try to make sure that documents within, or like that match that we use with that schema actually fit the schema. So it wouldn't let us make age a string, for example, or it would try to give us an error if that happened. So what this actually looks like from Mongoose's point of view is, let's say we have in API.js some operations on a model. And a model is what Mongoose uses to let us interact with our data, with our MongoDB database. And our model is associated with some schema. Say, for example, name mapping to string and age mapping to number. That model is going to talk to the user collection inside the database. And it's going to use, and like because of that, it's going to use the user collection to get back data that the user requests or delete data that the user wants to be deleted. So Mongoose schemas let us structure MongoDB documents and specify what fields they have. Each collection should have a schema. It'll make your life easier, I promise. And you can change the schemas when you have to, because you don't really work with that much data when working on a prototype. Or when working on a prototype, which means that it's pretty easy to restructure your data as you have to. So schemas let us nicely organize a Mongo database, whereas this is something you kind of get for free out of a relational database in exchange for paying a lot more like upfront in terms of being forced to structure our data a certain way. There are lots of Mongoose schema types. We have strings, numbers, dates, buffers, which are basically just like byte strings, like a lot of bytes. Booleans, mixed, and mixed means it could be any of these. Object ID and array. So you can also read more about these types at this link, but object IDs are basically references to other objects. You can imagine an object ID as like saying this object contains this other object, but we don't store it inline. Instead, we like store it in some other collection, and you can go there to find the object, And arrays are over these other types. You can have an array of strings, array of numbers, array of dates, array of buffers, and so on. Mongoose has a concept of a model, which lets you make documents, get documents fitting a model, host documents, or really do anything with documents that fit the model. And models are built on top of schemas. So to make a model, you need a schema. And you can think of a model as basically a fancy object. Because when we have a model, we can also use it to query or modify the database, in addition to actually accessing data directly. So to make a model, what we're going to do is first we're going to define a schema. And we can do that with the new keyword with a mongoose.schema object. And we pass in the fields and types for our schema. And then we make a Mongoose model by first passing in the name of the collection. And so user is the collection name. If we named it users, for example, the collection would be called users. So that's how Mongoose knows what collection to look for or create if it doesn't exist inside of your MongoDB database. And we also pass in the schema, so that way Mongoose knows what the documents should look like when it retrieves them retrieves them from the database. So to make a document, what we can do is first we can define our model. Then we can use the new keyword again with our model to and we pass in pass in an object representing our model or representing our data. And then we call save on the object we've created. And then, well, so save returns a promise. And with that promise, we're going to, once it resolves, log that we've added the student's name to the database. We know that student has a name because when we constructed our user, it also had a name, and our schema had a name in it, so we know that student.name should exist. The reason why we use promises for this is because saving to a database is an expensive operation. You have to talk over the network to the database, which takes a while. The database has to write to some file internally, and that also takes a while. So we use promises to speed it up and let us do other work while we're waiting. So putting it all together, I said that we were going to have some boilerplate code for connecting to the database. And first, we're going to be importing Mongoose. Then we're going to define our SRV for connecting to Mongoose, which is kind of like a URL, but it also includes some authentication information. Then we're going to define our database name and some options for how we're going to connect to Mongoose or to MongoDB. And then we call mongoose.connect and we pass in these options in the SRV. And if it succeeds, we're going to log connected. Otherwise, we're going to log whatever error came out so we can debug it. Then we define our schema by mapping the keys to the types of the values. And then we make a user from that schema against the right collection, which in this case is user. Lastly, we make a new user by using the model that we got and passing in the data that we want to give it. And we save that to the database. And after we finish saving it to the database, because save returns a promise, we have to use .then, we're going to log that we added the user to the database. So in Atlas, if you ran this, you would see that our collection now has this new field, or has this new document with the right fields, name, age, and pets. And the pets data, for example, matches what we expect because at index 0, we have Cloudy, which was the pet that we put in our code. Right here. However, there's something we didn't actually add ourselves here, which you might have noticed. There's this ID field. Where did it come from? Well, its type is object ID, first off. And every object gets assigned some unique identifier. The identifier is the ID is assigned to the ID field. And this is really helpful when we have a relationship between documents. Like, for example, if we want to store a parent-child relationship, or with our comments and our stories, we want to attach we want comments to be aware of what their story that they're attached to is. So we can use the ID for that, or we can use the story's ID for that and store it in some field of a comment. So when we're trying to find documents, the first argument to .find describes how we're going to filter the collection. It's very similar to what we put into MongoDB Atlas. And so we pass in the empty object, and that means we're doing no filtering at all. So we're going to get back everything in the user collection. Then, well, first off, find returns a promise. Find returns a promise because, again, it's slow to talk to the network and read a file. So we're going to make sure we can do other work while waiting for that to happen. But once we have back our data, we, given the users, log how many users we found. That's because we just want to show that we got back the data. You can do more than that with the data. You can do basically anything with the users object or with the users array if you want. So here are a few examples. First, we have one example that returns all the documents. We went over this already. Then we have one that returns all users age 21. We specify that by mapping age to 21. And we do the same thing in our then statement. But the reason why this filter works is because we specify that age should be 21. So Mongoose only gives us back the documents that have an age equal to 21. And that's relatively simple, but the last one might have this surprising behavior. So the last one returns all users age 21 that are also named Tim. And we specify that by, in our object, giving both a name field and an age field. And any users returned by this find query will both have name Tim and have age 21. So it's like a Boolean and, it's not an or. It's not going to be people who are named Tim or who are age 21. It's people who are named Tim and are age 21. So because of that, you can use this object with basically an arbitrary number of keys to get increasingly narrow queries, which is pretty convenient when you have very specific like requirements. For example, you might want to know all comments from a user that are from a specific user that are on a given post and also contain some keyword in them if you're searching. So yeah, you can add an arbitrary number of parameters to the filter, and well, no more than there are actually fields in the document or in the schema, but that's because you can't filter beyond that. Yeah. And we can also delete documents. Also, I will note that you can use fields inside the schema, but they have to actually be in the collection. So you could use ID if you wanted and you had a specific ID you were talking about. But to delete a document, we can use the delete one function, which deletes the first user in the collection named Tim. And we also have delete many, which deletes every user in the collection named Tim with this filter. Note that we use the same filtering syntax for delete one and delete many as we did for find. And again, delete one returns a promise because writing to a file is expensive and network communication is expensive. So we want to be able to do other things while waiting. In general, here's some documentation about Mongoose schema types. You can also have things like validation for making sure that documents in your collection have properties beyond just having the right type. And there's the Mongoose guide if you have more questions, or you can ask in the question stock around Piazza. We're now going to get into the workshop of attaching the database to your Catbook app, and I'll hand it off to Joyce here now.
Okay. We're gonna switch the laptops to show the code, but while we do so, if you can navigate to the Mongo snippets, okay, sounds good. So now we're going to start our workshop. So open up your Catbook and also make sure you see your intro to databases cheat sheet, and then also you're on your MongoDB page, and then you have tried to connect, and you have your URL. So this was part of your homework, but in case you forgot, you can just click connect, and then you should be able to see your connection string. Okay. So for our workshop, what we're going to be doing is essentially we're going to hook we have our backend system that is connected to our front end, but now we're going to connect our backend to our database. And so to do that, we have to first create our models for our comment and stories. And then we're also going to modify our backend API endpoints so that instead of fetching data from a hard-coded data object in our server.js file, we're fetching data from our database. So again, it would be nice if you can pull up the Mongo snippets PDF, and then we're going to connect our MongoDB. So first, you can go to your cat book and hit reset -- hard, hit fetch, and then check out W6 starter. Okay. Once you have checked out, again, you can get your URL, and if you don't have a URL, what you can do is go to the slides, and if you go to the slide 48, you can just copy the link. And so with this link, you cannot log on to Atlas yourself and check your database yourself, but you should be able to connect to MongoDB and follow along with our workshop. So, okay, raise your hand if you were able to get your link. Okay, raise your hand if you need more time. Okay. So it seems like most people are good, but now we're going to go to server.js and we're going to paste our Mongo connection URL. So in server.js, we have this to do step 1, and you will just want to paste your URL there and make sure there's a part that has bracket password. Make sure you replace it with your MongoDB password. Zoom in. Okay. Okay, some feedback was that they wanted us to use a higher contrast skin for our VS Code. Is this easier to see for the back? No? Yes, doesn't make a difference? Okay. Okay, so once you have pasted your URL, raise your hand if you need a minute more. Okay. Okay, we'll just wait, but paste your URL here in server.js and to do step 1. Okay. So once you have pasted your URL, you can do npm install and npm start. Okay, once you run npm start, you should be able to see a connected to MongoDB. If you don't see it, please add yourself to the help queue. But basically what we have right here is when you connect successfully, we have an output connected to MongoDB, and otherwise it will say an error. So if you run npm start and you successfully connected to MongoDB, then you should see this message in your console. Okay. Show of hands if you were able to see connected to MongoDB. Okay. Show of hands if you need a little more time. Okay. Okay, raise your hand if you're getting an error. Oh, okay. When you copy your URL from here, do you replace your password? You do, and you also replace the brackets. Okay, so you don't have brackets. Okay. Yeah, add yourself to the queue. Oh, so if you recall, you made an account in your setup instructions. So a database user account, and then you should replace the password with that user's password. So it's not your MongoDB. It might not be your MongoDB account. It might be the database user. You replace the brackets. Oh, see the what? Oh, you should see it in your terminal for where you ran npm start. Okay, raise your hand if you're still working on connecting. Okay. If you see an error, definitely add yourself to the help queue. Oh.
It's like a half-hour workshop.
It was an hour. It was originally an hour and a half, and then we driving.
Okay.
Went to an hour.
Like from where to start.
From where I start, I feel like we haven't really started, but like it shouldn't take too long. I feel like though it might take a little more than 30. Like 30. Yeah. I'm sorry. Okay. If you were able to connect, that's good. If you aren't, please add yourself to the help queue. But for the sake of time, we're going to continue. So we have connected, and then we should see our connected to MongoDB message. Our next step is to create comment and story mongoose models. So Jay went over what collections were, what documents were. So for our cat book, we're going to have two collections. We're going to have our story collection and our comments collection. And our stories will have our story documents that have our ID and the content. And then comments will have ID, parent, content. So our first step is to add comment and story mongoose models. So how are we going to do this? If you go to models and then open story.js, you should see 3 to-dos. Okay, so we want to define each story to have a creator name and content, and we want each of these types to be strings. Does anyone have an idea of how we can do this? So what we can do is we can actually refer to our cheat sheet, and we can see right here we have creating a schema and creating a model. So here is example code on how we can do this. So remember, with our schema, we can tell it what we want each story to have and the type. Okay, so we are going to create our models to have creator name and content, and we're going to use this using schemas and Mongoose models. Okay. So the first step we're going to do is in our story.js within our models folder, we're going to import Mongoose. Okay, so now we have imported Mongoose using require, and we can access the function. So now we can define a story schema. And recall that we wanted our story schema to have creator name and content with type string. So we can create a new mongoose.schema and give it creator name with type string, and then content with type string. Okay. And then we're going to export our model so that our other files can access it. So module.exports. And we're going to create our model. And the model function, it takes a name. So this is the name of our collection, and we're going to name it story. And then we're also going to give it the story schema. So now we've made our schemas and models for the story. Okay. Show of hands if you were able to make your story schema and model. Okay. Show of hands if you need one more second. Okay, so I'll have the code up here, but I'm just gonna move on for sake of time. But if you're already done writing your story model, you can now make your comment mongoose model. And now it's your turn, but it should be very similar to what you did for stories. But instead, you want to make sure that the schema also has a parent field. So normally we would recommend you write everything yourself again for the sake of learning, but because we're short on time, you can copy and paste your story schema and adjust it in your comment.js file. Okay. Show of hands if you were able to attempt your comment mongoose model. Okay. Show of hands if you need 1 more minute. Okay. So I'm gonna go ahead and show the solution. So for comment.js, it's very similar. We want to import mongoose. And then we want to define our comment schema. And we're going to give creator name, parent, and content. And then we are going to export our model again. And we're going to name our collection comment and then give it the comment schema. Okay. So no worries if you didn't get to finish your models. We're going to check out the next step. So for our step 1, we're going to link our backend with our implemented MongoDB. So go ahead and get reset -- hard and then check out W6 - step 1. Yes. Okay. So everyone, hopefully you were able to check out W6 step 1. So now we are going to open our API.js. And so here, now we have our routes, but we have to redo them so that they are instead fetching data from the database instead. So first thing we need to do is we have to import the comment model. And here we see to do step 1. And basically, it looks very similar to what we have above. So instead of const story, we can do const comment equals require, and then fetch the file that has our model. Okay. Oh, thank you. Okay, now we have imported our model that we exported from our comment.js file. So the next to do is for us to fill in the to do for stories. So the endpoint wants us to return all the stories saved in the database. So how would we do this? I'll give you guys 1 minute to go ahead and talk to your partner, but go try to find a relevant code in Mongo snippets. Okay, so how would we do this? In our Mongo snippets, we can see that we have finding with a query, and then we can use student.find, and that will go ahead and find whatever documents match with our query. So what do we put in our query? Here it says if we put an empty query, it'll return all documents. So basically we can use .find with an empty query, and then it'll get us all of the documents. Okay, so here is the solution. So we can use story and then do .find, and then we give an empty query. So we get all of our documents. And then recall this is a promise. So once the database returns with all of our stories, we want to then get the stories and send it to our front end using res.send. Okay, raise your hand if you need one more minute. Okay, seems like most people are done. Okay, so now let's implement post/story. So the server will create a new story based on content. So where do we get the content? If you recall, in the front end, we have our React component called new post input.js, and this is where our users can input their new stories, right? So we pass in this content into our post body. So in the backend, does anyone recall how we can access information that was passed in from the body? Does anyone recall the keywords? It starts with rec dot. Yes, rec.body, and then for this specifically, we can access it using rec.body.content. Okay. So remember, for GET requests, we can access content being sent by rec.query, and then for post, we can use rec.body. Okay, so how are we going to implement post/story? So recall that we want to create a story object, and then we want to save it. So if we go to our cheat sheet again, there is a part that says inserting a document. So here we can define, here they define a student object, and then they do that object.save, and then they can basically, we would send it back to the front end. So what would that look like? We can create our new story object, and we can define new story, and then we have to give it the values we want for this new story. So how do we know which fields to put in? If you recall, we made our schema in story.js, and it requires a creator name and a content, which are of type string. So now we can use that information. So we know we need a creator name, and this should be type string. For now, we don't have any accounts. So like we don't know what users' names or user names are. So we're just gonna hard code it for now. You can hard code it with a string saying like your name, or we have a variable called my name right here that you can change. So I'm gonna use my name and change it to be blah blah. Okay, and then we're gonna give it content. And again, we can access content by accessing it from rec.body content. Okay, now we have our new story object. We can call save on our new story object, and it'll save it to MongoDB. And then we can do .then, and then the story object that is returned from MongoDB, we can send it to our front end so that they can display. Okay, hands up if you need more time. Okay. Is there any questions so far? Hmm? Come from? Yeah, so that's a great question. So new story.save, basically we're saving to Mongo, and then Mongo will return our story object. And then because this is a promise, we can use .then, and then on whatever is returned from new story.save, we can send it back to the front end. Does that answer? Okay. Okay. Are there any other questions? And raise your hand if you want a little more time. Otherwise, I'm going to move on. Okay. So now we can run npm start and npm hotloader to run our backend and our front end, and we should be able to navigate to localhost 5050. So npm start, npm run hotloader. Okay. And then we can go to localhost 5050. And I already have stories and comments in my database, but you guys should see a blank screen and be able to post your own stories and see it show up. Okay. So show of hands if you don't see or aren't able to post your stories, feel free to hop on the help queue, or just catch up by using git reset -- hard and check out W6 -- step 2. Okay, show of hands if you were able to see your stories being posted on your website. Okay, nice. We're gonna continue on, so go ahead and check out to catch up. Okay. So now we're going to do it for comments, and it's actually going to be your guys' turn. So what we can do first is review. So remember, in the get body, in the front end, they pass in our parent ID. Oh, in a get query. So how do we access this from the backend? Does anyone want to volunteer? It starts with rec. Remember, this is get. Yeah, rec.query.parent. So this is how we can access the value that's being passed in from the front end and our back end. So our next step is to implement, to do step 2, and we want to have our post endpoint or our get endpoint for our comment. So right here, we have already given you some like baseline code of how it's going to find all the comments, but we need to input the query parameter. So go ahead and try, and feel free to refer to the Mongo snippets document on how to query. Okay, raise your hand if you need more time. Okay. So I'm gonna go ahead and reveal the solution. So here we can pass in our query and we can say for the parent field, we want to get the comments that match rec.query.parent. So now this will only return the documents that have the field of parent be the same value that we are passing in from rec.query.parent. Okay. So I'll leave that up on the code. And then I'm going to move on. Actually, raise your hand if you want me to pause here. Okay. So now we're gonna do our post step. So for post, remember that in the front end again, we are passing in both the parent, but now we're also passing in content. And remember for post, we're using body, so we can access these values using rec.body. Okay, so now it's your turn to implement the post/comment endpoint. And for a hint, you can refer to the post/story endpoint that we made, and also weblab.is/mongo snippets. Okay, for the sake of time, I'm gonna go ahead and reveal the solution. So it's very similar to post/story. So again, we can create a new comment object and we want to pass in the fields. So if you recall, we can again go to our model schema and see what fields we need to define. And we need to define creator name, parent, and content. So creator name, I'm just gonna pass in my name. And then parent, we can get from rec.body.parent. And content, we can also get from rec.body.content. So now we have to find our new comment object. We can again do new comment.save, and then we can return the comment to the front end using res.send. Okay, once you have your post comment endpoint, you can go ahead and run, go again to localhost 5050, and you should be able to now post and see your comments. Okay. So Now, in localhost 5050, I should be able to write hello. And it should close. Are people able to create comments? Okay, awesome. Okay, nice. So now you should see exactly the comment corresponding to the story. Now, if you weren't able to complete, you can go ahead and check out the complete version. But now we're gonna show in MongoDB itself in Atlas, you should be able to go and see all the comments that you were adding stored to your database. So you can browse collections. And I can go ahead and write a query. So creator name web lab. And I should be able to see my comment. Oh wait.
I'm going to what's the web lab?
So basically, if you go to Atlas, you should be able to see your comments. Yeah. And you can filter them using the query, writing a query here. Okay, so we're going to, just to summarize, we have just now connected our backend to our database, and we were able to fetch directly and post to our database from our backend.